This is Algebra 2 at Trig, Unit 3B.2b. We're going to simplify complex fractions. A complex fraction contains a fraction in its numerator or the denominator. Our textbook gives two different methods for solving, or simplifying, let's call it, complex fractions. We're going to focus on method number 2, because that's what the pre-calc teachers prefer. We're going to eliminate all the little fractions, and we're going to create one big fraction. We're going to do that by taking the LCD and multiplying it to all the parts of our complex fraction. We're going to distribute the LCD to each term. And that should eliminate the denominators of each of these little fractions. So let's go ahead and try this. We look at this first example. And what is our LCD? What is our least common denominator? X times x plus 4. Every denominator has an x in it, or it has an x plus 4 in it. So the common denominator is x and x plus 4. So we're going to multiply that to the top fraction. We're going to multiply that to the bottom right fraction and to the bottom left fraction. I would write it, in this case, 3 times, because you have 3 separate fractions. When you multiply it to this top fraction, you're really just multiplying it to the top number. But you might consider crossing out what's the same before you even get into the multiplication portion of it. So this is now just 5 times x. That's 5x. Down here on the bottom left, we're looking at what could cross off with our denominator, so we don't even have to worry about multiplying that part. And that's going to be the x plus 4. So that just leaves the x times 1. And that's going to be x. Plus, on this one, the x's cross out. And I'm left with 2x plus 8. So we can simplify this by saying x and 2x is a total of 3x plus 8. And that's as simplified as it gets. So you want to look at this and try to decide, would you consider crossing the x's out? You can't do that because of the plus. All right, let's go on to the next one. What is our common denominator going to be? X and x minus 5. Every denominator is either x or it's x minus 5. That's what makes your common denominator. So we're going to take that amount and we're going to multiply it to each of the fractions. In this case, we're going to multiply it 4 different times because we have 4 different fractions. So it's going to be x times 6 to give us 6x. It's going to be 1 times x and 1 times negative 5 to give us x minus 5. Here the x's cross off and we get 3x minus 15. Now you got to watch this part. You got a minus. The x minus 5's cross off, which is helpful because we're not going to have a binomial. We don't have to distribute. So it's just negative 2 times x, which is negative 2x. So our like terms are going to come together. Looks like we're going to have 7x minus 5 and x minus 15. So this is a situation where you cannot cross x's out. You cannot reduce the 5 and the 15. Now, looking at this one, you've got to look over it. You notice that it's a complex fraction because it has fractions on top, it has fractions on bottom. You notice that the denominator here can be factored apart. So I would suggest to rewrite this by factoring that one apart. So now we're going to look for a common denominator. What do each of the denominators all have? They either have an x plus 4 or they have an x minus 4, and in this case, this one has them both. So we're going to multiply x plus 4 and x minus 4 to every fraction, because that's what our common denominator would be. So in this case, the x minus 4's would cross off, and you'd be left with 3x minus 12. You have to distribute that through. Three x plus 12. Sorry if I said minus. Minus, in this case, the x minus 4's cross off, the x plus 4's cross off, and you're just left with 6. No other multiples. In this one, the x plus 4 is going to cross off, and we'll get 3x minus 4. Actually, 3x minus 12. You've got to distribute that to both, of course. And 1 times is going to give us x plus 4. So we collect like terms, collect like terms, collect like terms. So that's 3x plus 6, and this is 4x minus 8. Even if you factored the numerator apart, and even if you factor the denominator apart, you'll see that nothing crosses off. So this one here would be okay. But true, we do talk about factoring the denominator. So either method, in this case, it's just as GCF, but either way. Here for example number 2. A college student drives home for the weekend. The distance between her home and her dormitory is d miles. Her average speed coming home is r1. Her average speed driving back is r2. So her average driving trip is given by this complex fraction. If we had distance equals rate times time, you would divide by the rate to get the time by itself. So that's where this distance is being divided. And each of these are individual to the different trips. So we want to simplify this using our complex fractions. So this is 2d. You might call it 2d over 1. Just so if you're looking for that denominator, the denominator of 2d is just 1. Then you have d over r1, and we have d over r2. Those are not square roots. Those are r's. So our common denominator is going to be r1 times r2. So we're going to take r1 times r2 to every fraction. Nothing crosses off here with the denominator. So this is 2d times r1 times r2. The r1's cross off. We get dr2. The r2's cross off. So we got dr1. And that looks pretty good. But you might notice r1 times r2 for the top, of course. We can pull this d out in front. And if we factor the d out, the GCF out, we're going to be left with r2 plus r1. And then those d's can be reduced, because those d's are not added to anything additional. Nothing that it's multiplying is being added to anything. So here we get 2 times r1 times r2, and the denominator is r2 plus r1. Or you can write it the other way. Nothing can be crossed off there. So this complex fraction is a U-try. So you go ahead, give this one a thought, pause the video, give it a try, run the video, and see what you think. So here we're looking for our least common denominator, or even least common multiple. What do 10, 5, 2, and 4 all go into? They all go into 20. So we're going to multiply 20 to all of our terms. So 10 goes into 20 2 times. 5 reduces with the 20 to become 4. 4 reduces with the 20 to become 5. And 2 reduces with the 20 to become 10. So that's going to be 2x minus 4x and 10x minus 15. If you want to factor out that common denominator, you're welcome to, or common factor out of the denominator, you're welcome to do that.
So if you don't, if you just have 10x minus 15, that's only right.
I don't mind it being written with this. If it could be broken into two separate binomials, we'd really expect it to be factored apart for that. But if it is just a GCF, nothing crosses off, it's okay not to have that reduced. Yes, it would. That would be a 2x because it would be 5 times 2 to make 10 and 5 times 3 to get 15. Good eyes. Can the 2x's cross off? 2x's cannot cross off because that 2x is being subtracted with the 3. 3 is being subtracted from the 2x. All right, now this one is just notation. Letter B, the negative exponent looks intimidating. So this is 4 minus 1 over k squared. That negative exponent means to put it into the denominator. And then this is 2 over x to the first power minus 1 over x squared. So once we put it into that form, it should make a lot more sense. Our common denominator, notice that they all, this one doesn't have anything, but they all have k's in them. These two actually have k squareds. So you have to take the largest exponent. So we are going to multiply, maybe, k squared to every fraction. When we multiply it to the fraction, we're going to get 4k squared minus 1. Here, the k is going to cross off, and I'm going to be left with 2k minus 1. And hopefully here you don't make the mistake and think that 2 goes into 4 and k goes into k and 1 goes into 1. That is not how this is getting simplified. We can simplify this by recognizing this is the difference of two squares, 2x minus 1, or 2k for this matter, 2k plus 1 over 2k minus 1. And those are going to cross out completely. It does not reduce this way. It reduces because these are the difference of two squares. 2k plus 1. So we go on to our last one. Go ahead and pause the video, try it on your own. Come back and play it and see how you did. So we're going to look at our common denominators, and we notice x minus 4, x plus 1, x minus 4, x plus 1, x minus 4, x plus 1. Every denominator is either x minus 4 or it is x plus 1. So we cross off here, we distribute through, and we get 3x plus 3. X minus 4 is cross off, we leave with x plus 1, plus 3x minus 12. That's going to leave me 3x plus 3. That's 4x minus 11. You could factor the numerator apart, but there's no need to do so because it's not going to cross off. I don't have an x plus 1 on the bottom.